Hello guys, welcome to the channel. In this video, we are going to locally install this Llama-CPP-Agent tool, and we will do inference with it with the local model, plus we will also see some of the function calling capabilities. Llama-CPP Python is a package that provides low-level and high-level access to llama.cpp, which in return is a library for text completion and other NLP tasks. This project, Llama-CPP-Agent, is based on these libraries. This in return provides a lot of other functionalities, as I mentioned earlier, function calling, tool usage, even it provides bit of a rudimentary RAG and few other things. But I see it as more a low level or a very bare minimum sort of inference which should be fast with the local models without any frills. So in this video, we are going to install it in a step-by-step way because installation can be a real pain in the back for this tool. To be fair, it's not straightforward. It is highly dependent on the libraries and your CUDA setup, your CPU setup, and all that sort of things. So I will in detail tell you what I am using, and then if you follow those steps with exact those prerequisites, you should be able to get it installed. For the local model, I'm just going to go with this Mistral's quantized version in gguf format from block. So you would have to manually download this file, and I will also show you how to do that shortly. Before we proceed further, let me give a huge shout out to Mast Computes who are sponsoring the VM and GPU for this video. I am using Ubuntu 22.04 and my GPU is NVIDIA RTX A6000 with 48 GB of VRAM. If you are looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. So do check them out. Now coming back to this, let me open my terminal first. So this is my terminal, as you can see, Ubuntu 22.04, and let me quickly show you my GPU card too. So this is my GPU card, and more importantly, at the top right, this is a CUDA version I'm using 12.4. Let me clear the screen, and this is important that you should have the exact CUDA version, otherwise this may not work, unfortunately. Okay, so let's clear the screen. Now let's first download a model and then we will go from there. So create a local directory called as my models, and then let's go into that directory. Sorry, let me clear the screen. Now let's go to that Hugging Face card of that model, then click on these files, then scroll down and then just select any model of your choice from here. For example, I just want to go with this one, so click on this link, and then in order to download it, what you need to do is to scroll down, and then you see that there is this download link. Right click on it and copy the link. Once you copy its link, go back to your terminal and then do wget and then paste that link. If you are using Windows, simply right click and download it. So it is going to download it on your local system. In order to save time, I already have downloaded it. So you see, I have already got this Mistral here, and this is what I'm going to use for this video. Okay, so let's clear the screen. Now, in order to keep everything separate and simple, let me create a Conda environment. So Conda lets you, it's not mandatory, but I would highly encourage you to install Conda first. If you don't know how to do it, then please search my channel. I already have done it. My Conda version is 24.5.0. Let's clear the screen and let me create the Conda virtual environment with this command, which is creating a Conda environment LC agent and also activating it in the same go. Let's wait for it to finish. Shouldn't take too long. And don't worry about all of these commands. I'm going to put them in my blog and I'll give you the link to it in video's description. So Conda is activated, and now let's create this llama-cpp python first, because that is a prerequisite, and as I mentioned but it is earlier. And make sure that you run this command with CUDA 124, which is my version. Let's wait for it. It is going to download it and install it. This is going to take minute or so. And that is all done. Let me clear the screen. Now, if just in case your CUDA version is different, make sure that you go to this Llama-CPP website at this github.io and then select the exact file of with respect to your CUDA version. That is very important. Okay, so that's all done. And now let's install that actual thing which we are working on, Llama-CPP agent with pip. Let's wait for it to get installed. And that should be good enough. That is all good, thankfully. Let me clear the screen. And now let me install my Jupyter notebook, and because that will make it easy to show you how it works. So I'm simply installing this Jupyter notebook and then launching it. It should install it here and then it will launch it in my browser in a second or two. Shouldn't take too long now. Almost there. And it is opening it in my browser. So let file, new, and notebook. And there you go. So we have our notebook ready, everything is installed. And now let's try to see how this thing work. First up, let's import the class of Llama-CPP Python and Llama-CPP Python provider. So first I'm going to do the inference with the local model. We'll chat with it. First up, I'm importing some of the stuff. You can ignore that warning. Second up, let's define our model or initialize it. So here I'm providing the full path to the model file which we downloaded. Then I'm just giving it the batch, how many layers I want to upload to GPU and all that stuff. So let's run it here. And this is going to tell you all the information about models, how many layers are there and all that stuff. Let's wait for it. Yep, that's all done. Okay, so that is done. Now let's create a provider. The provider means that what is going to serve this model locally. So we are just going with Llama-CPP provider. That is done. And now let's do the inference. Let me paste the code here. So for inference, we need to use this code. So in this one, we are simply importing stuff here, and then we are initializing the agent, and we are telling it the system prompt that what exactly it is supposed to do. And then because we have used Mistral model, so we are going with message format type or prompt template of Mistral. Then we are just giving it a prompt, hello world, and then getting the response back. Press enter, run it, and then you should be able to get the response back shortly. There you go. So hello and all that stuff. Okay, so and then you can just talk with it more. You can just ask whatever you want to ask. What is happiness? And then just run it, and then you see what is happiness. Happiness is subjective feeling of contentment or joy. So this is how easy, quick it is to use inference with it. Now let me show you how you can do the function calling with it. Let me paste the whole code here, and then I will try to explain as what exactly we are doing. So first let's read the code. We are simply importing some of the libraries for function calling, and this is just a small function which just passes the receiving message back to the user. Now, what is function calling, by the way? Function calling simply means that you use this function calling feature of this tool to enable the large language model to call any external API or external function. So what happens is you provide a natural language question to model, and model creates a signature of the function, or basically it creates a function call which you can call to get your external API and all that stuff. So we have defined a function here, or function signature, that this is the name, these are the parameters, and then this is what it does. And this is extremely important, that you need to give this description as what exactly this function does, because this is what model reads, and then whenever a user asks a question in natural language, it uses this information to map it, and then it calls this function automatically. For example, if you have like 10-20 other question, functions and user asks a question, then with the help of this text, model is able to identify which function needs to be called. So you have defined a function which is taking some parameters, it is defining what it does, then returning a result. And then these are some of the settings. As this is what we are telling LLM, that these are the functions which we want you to do, and if there are multiple functions you can call them in parallel. And that is where we are initializing this Llama CPP agent with the model, and then system prompt, that what it needs to do, that use it in JSON format. And then here you can use Mistral, which is better if you use Mistral, I guess. Okay, I'll just use it. This one, if it doesn't give it, we'll change it, no problem. But it's always good idea to use the proper template. And then I'm just printing that function call. So if I run it here, okay, it says user input is not defined because I forgot to put it in there. Let me quickly put it there. So this is what I forgot to put it in here to call that function. So you see what we are doing here is we are just giving it a natural language text that calculate a to the power of b, and then LLM is going to take this text, map it with this text of all the functions, and then it will identify it. So let me run it, and you see that this is what it does. So if you scroll down, this is where it has given us that this is the result of the function, and then it has called it. Amazing stuff. And this is the function call. It is just a name error because I haven't called it. Otherwise, you see, this is the function call which it needs to make with the help of LLM. Now, you can not only do one function, but as I said, all you need to do is to just specify multiple functions, and it is going to use it in parallel. You can also do the RAG with it, and you can do a lot of other stuff. So for example, if I show you the previous output, so this is the function call which we did, and from here not only you can call this function which has returned us the result, as you see, this is the result, multiple function calling, and for the RAG you can embed your own data and it is going to give you the response as per your own context. So I would say pretty a neat tool when you are looking to do a low level inference and you want to build your own application from scratch. So yet another good option. But I think as far as installation is concerned, that could be a bit of issue once you get it out of the way. Hopefully this video would help. I think pretty fast and quick tool. That's it guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.